Hi, Matt Roscoe here at the University of Montana with a quick video on how to construct a perpendicular bisector to a segment using the rhombus method. Okay, well let's suppose I have this segment AB, and what I'm trying to construct is the perpendicular bisector to the segment. So that's some line that cuts the segment in half and does so in a manner in which the segment or line that cuts it in half is perpendicular or at a right angle to AB. In other words, it's something like this line right here. But how to find it is the big question. And lucky for us, the rhombus provides us the answer. So if we just construct a rhombus using A and B being opposite points on the rhombus, then from what we have proved in class, we know that the diagonals of a rhombus perpendicularly bisect one another. And all we'll have to do is construct the other diagonal of the rhombus, and it will be by, I guess, the properties of logic and congruence of triangles. It will be the perpendicular bisector of AB. So let's go ahead and construct a rhombus. Now, to construct a rhombus, all we need to do is construct four sides of a figure that are all the exact same distance. We have to be a little bit careful because we can't pick any distance. For example, if I picked a very short distance like this, I can see that that distance from A and that distance from B won't intersect. So it seems to stand to reason that all we need to do is make sure that the distance we choose for the sides of our rhombus be longer than half the distance from A to B. That'll ensure that the sides will intersect. So here's what I'm going to do. I'm going to construct a circle centered at A with a distance that's over half the distance from A to B. And any point on this circle will be exactly that distance from A. If I do the same thing from B, any point on that circle or part of a circle will be the same, that same fixed distance from B. So these 2 points, let's call them, I don't know, C and D, are the points that are exactly that distance from B and that distance from A. So we can see that if we connected up this particular figure, what we would have is a rhombus, because those two distances are the same and these two distances are the same. So the red lines are all congruent because of the construction. So if the red lines are all congruent, then the quadrilateral ADBC is a rhombus. And if it's a rhombus, then we know that the line that the diagonals of a rhombus are perpendicular and bisect one another from our proof in class. So I'll go ahead and draw in an extra line here in a different color, and that will be our perpendicular bisecting line. And so there you have it. The line DC must be perpendicular to and bisect the line AB, or I should say the segment AB. A quick check of this, of course, would be, well, is it really perpendicular? If I put a piece of paper there in the corner, it sure looks like it's a right angle. And is it really bisecting? Well, it looks like I drew my segment to be 3 inches or so, and about 1.5 inches is where the blue line crosses the black line. So a little bit of empirical verification, but of course the logic guarantees that this is true to begin with, so we can go ahead and mark these two as the same length, and of course the angle as right. Okay, hope you've enjoyed the video.